Good morning, it's me, Mr. Chu. I'm back from a video in geometry. Today we're going to be looking at prisms and cylinders, and we're going to be calculating volume. So real quick, just a rundown of what volume might be for us. Volume is a measurement in cubic, meaning 3 dimensions, and what we're going to be doing is measuring the amount of space or the capacity on a 3-dimensional level. So for example, volume is what the amount of air it takes, for example, to fill a basketball, or the amount of air in this room, the amount of space that we can have, our capacity on a 3-dimensional level is called volume. If you think about, like, for example, the amount of water in a swimming pool, that's volume. The amount of soda in a soda bottle, that's volume. So we're looking at capacity basically, and we measure that in a cubic, meaning we're going to be multiplying 3 different things to get our answer. So the first thing I want to look at is the formula they give us on standardized tests like the SAT and ACT. They give us this: volume equals capital B times H. And most kids get kind of confused because they don't really understand what capital B stands for. And it's kind of a generic formula. The capital B stands for the base area. So when you talk about the shape, you have to type what is that shape, and then from there we want to work with the area of that shape and then multiply it by the height of the particular object. So when I start off with this first one, my way of doing this, or my way of explaining this all the time to my students, is always talk about the name first. So this is a rectangular prism, and the key word being rectangle. So what I want to do is, on the side of my paper, I want to go ahead and look at this picture, and I see a rectangle on the front, and it's 5 by 10. And so when I go to do this base area, the first part I want to do is the area of the rectangle, which in this case is 5 by 10. Because our area for our rectangle is base times height. So then I want to take, after I take that particular measurement and find the area, I now need to multiply that by the width or the height or the thickness. I don't know how you want to say this. There's so many different ways, but I like to think of it as how thick or how many stacks of rectangles do I have. And so this is the front rectangle right here going across the front, and I have a stack of 3 of them, if you will, meaning like 3 inches thick. And so what I do then is times 3, and I get 150 inches cubed. So my way I like to do it is I like to think of it as the third measurement, what they call H in the formula. I like to think of it as the thickness, or how tall is the stack. So when I look at that, I always do that with the whole what's the first shape and the name, and then work from there. So like our second one, we got a triangular prism. And again, the key word is triangle. So off to the side, I draw my triangle. Now sometimes they like to try to trick us by giving us numbers that we don't always need. For example, on this triangle, there's a number in here I don't need. And that would be that 5. Because our formula for a triangle is base times height divided by 2. Well, my base is 3, my height's 4, so I go like this. 3 times 4 divided by 2. That's the area of the triangle. So now I can say, well, that's this. Now all I gotta do is multiply it by how thick the stack is, how tall the stack, or how, whatever you wanna do. If I was doing this volume with, like, say, coins, I might have the how tall is the stack of coins. If I was looking at it in a textbook, you know, the stack could be the sheets of paper. How thick is it? So in this case, it's 2. So 3 times 4 is 12. 12 divided by 2 is 6. And 6 times 2 makes 12 centimeters cubed. So again, I like to just take the front shape, find that area, and then multiply by what you might call the thickness. And they call it the height because they're talking about it as it's laying down on its back, and how tall is it if it's laying flat on a desk. Well, I don't know how to draw things like that, so, and they don't often put them like that anyway, so just kind of do it this way. I think it works pretty good. All right, sometimes on number 3, for example, they might, if you notice on number 2, I gave you a number you didn't need. Well, on number 3, I shorted you a number. There's a number that's missing. So we'll start with that name part first, triangular prism. So I draw the triangle, and I've got 10, 13, 13, Well, something's missing because my formula is base times height divided by 2. Well, here's my base, but where's my height? I don't have that number. I don't have the height. 13 is not the height. Nobody measures your height leaning sideways. That's not your height. So what you have to do is we have to think about something that we may have used throughout the year. How can I calculate this? Well, if I make a little right triangle here and I take this 10 and split it into 2, I would have 5 squared plus the height squared is 13 squared. That's 25 plus the height squared is 169. If I take 25, I get 144, which makes my height 12. So now I can go back and say, all right, base is 10, because we were 10 wide, we're 12 tall, divide by 2, and then all we got to do is multiply by how tall the stack is, or what's the height of the stack of triangles. In that case, it would be like 6, so times 6. Well, 10 times 12 is 120, divided by 2 is 60, and times 6 is 360, and then remember these little marks stand for feet cubed. I know my board's getting messy here, but that's all right. Here's our answer. All right, number 4, looking at what's called a trapezoidal prism. Trapezoidal. All right, so we got to break down what's the area of a trapezoid. So off to the side, I'm going to draw a trapezoid here. I'm going to draw that front face. Oh, I left it up there from yesterday. That's fine. Let me redraw it though, so you see what I'm talking about. I draw over here. I go, here's my trapezoid. I've got 12, and I've got 8, I've got a 5, and a 7. I don't need all them numbers. I only need 3 of these numbers. But here's the deal. When it comes to a trapezoid, we can't just do base times height, because the base of a trapezoid at the bottom is different from the base at the top. So the way we work this is we take the average of the two. So normally I would just say base is 12, but because this one's smaller at the top, I go like this. I say 8 plus 12 over 2. That gives me the average of the bottom and the top, and then I got to multiply it by the height, which in this case is 5. And then I got to do one more calculation. I got to multiply by how thick or how tall or what's the stack of trapezoids, and that's 3. So going through all this, got to do the old PEMDAS, please excuse my dear Aunt Sally, but we got 8 plus 12 is 20. Divided by 2 gives me 10. 10 times 5 is 50. Times 3, 150 meters cubed. So again, I threw you a number that we didn't need. All right, and our final one, we call this is a cylinder. And on the cylinder, we're based off of, what's our base area going to be? Well, cylinders are based off of a circle. So I'm going to draw a circle right here. And on that circle, I have a 12. That 12 stands for, in this case, the diameter. But my formula for area of a circle is pi r squared. So my capital B on this one is pi r squared. Well, my radius, if I look at it, if the whole thing's 12, my radius is going to be 6. So my formula goes like this. This is my capital B, pi r squared, and you notice there's r twice, which means that's 2 dimensions. And now when I multiply by the number 20, because that's how tall the stack of circles is, I end up with 6 times 6, 36. 36 times 20 is 720. And then since we're talking about circles, we have a pi. Now if I'm doing any normal problem, most of the time in the textbook, they might ask me just to leave it in pi, but if they ask me for a problem, like a word problem, they want me to solve it out, I'll just take my 720 and multiply by the number 3.14. All right, well, I hope this sums up volume for you for at least a prism and a cylinder. We'll be making another video on cones and pyramids and eventually on spheres. All right, thank you.